Hello and good morning, and thank you for joining me in my shop here. Today is October 25th, 2024, in case you're not sure of the year. And I have this radio back in my shop. Now, this was in my shop for a few days, a week or two ago. And to my surprise, it started working. I was really quite surprised. And I decided once it was working and seemed to be safe to operate, I would put it in my listening area and play around with it for a while, get more accustomed to its operation and what other problems it might have. One of the things I kind of forgot about was I was powering it the whole time from a temporary power supply, a 12-volt power supply here in my shop. And I could continue doing that, but the radio does have its own power supply inside it, of course. It has a power plug. And the reason I was not using it was originally when I tried plugging the radio in, it didn't operate. Now, I don't know if that has to do with the power supply, or I hadn't figured out yet how critical it was to have all these dials lined up properly. It could just have been that. At the end of the last video I did on this a couple weeks ago, after the video I did plug it in. I didn't have the cameras running or anything, so no one saw this, but I did plug it in and try it out. Here, because it suddenly dawned on me I'd forgotten about that, and the radio sounds like it's humming. So it sounds like a power supply, filter capacitor. Hey, no surprise in that. And if that's all it is, I'd like to change that capacitor and get this guy working with his own internal power supply. So that's what I'm going to do today. What is going on with the power supply? Is the capacitor bad? Is there something more to it? Can I fix it? And can I start using this radio with its own power supply instead of an external supply? That's the plan today. So first things first, though, I'm going to go drink a little coffee. Okay, we'll start by taking a look at the schematic, but first, look what's coming from the sun here. Yikes. Okay, so large schematic, and you usually find the power supply information kind of down in this area. But in this schematic, it's way up here. So we're going to zoom into this area here, and we'll take a look at it. Big schematic. Okay, here we are, finally. So let's look at the plug, as in this is the jack on the back of the radio that you plug the power cord into. This is where the DC supply was being injected, attached to the radio. We won't be doing this. Instead, we're going to rely on that. Now, I have shorted this switch here. I have a permanent short. The switch appeared to be broken. I have a permanent short here. Now, does that matter? Let's just think about that. So I'm going to throw this switch to AC. That's going to put the 120 volts onto the primary here. This function switch would be in this position, but this is closed. So this switch would be open, or flipped the other way from the way it's shown. And this one also would be flipped the other way. So lights are powered right from here. This is open. This is open. I don't think there's any problem whatsoever that this remains closed. Okay. Just a little safety concern of mine here. So we put power in here, and the power is going to go through the primary. It's got a filter here on the primary side. And on the secondary side, we have two rectifiers right here. This would be the output right here. Now that's not enough. There needs to be some filtering here. Where isn't there a big capacitor here? Oh, right there, right there. 500 microfarad capacitor right there. That's the guy I suspect is in trouble. These small guys are like RF filters or something else. And what's all this here? So regulator and a Zener diode. well, I'm not going to pretend to try to figure this out exactly. The output would be somehow affected by this to regulate it. I don't see it myself, but that's okay. I don't need to see it. This is what I need to see. I need to understand this. So we can plug the set in. We can listen to it running on its own power supply, and then we can make some measurements, especially on this 12-volt supply, which is I think available on the big J14 jack on the back of the radio. And we can look for hum and stuff like that, and then we can try to locate this. Maybe I could even start off with that. Try to locate this guy. And because do I have a replacement for him? I probably do. Okay. Yeah. There's not much more to this. All the different supply voltages are out here after a little bit of conditioning with these components. There was a time where I thought this resistor was shot, but no, I don't think so now. Okay, let's take a look at the radio. Okay, so the plug is here. The power supply is going to be right behind here, I'm pretty sure. This is a very heavy, this is a 35-pound radio, 35-pound transistor radio. The memo didn't get to the engineers about, once you use transistors, you shouldn't be building radios that weigh tens of pounds anymore. So here's the input. There's a resistor and capacitor right here. This is probably that part of that filter that we were looking at. Then it goes to a transformer. I guess this would be the transformer here. It's not very big, is it? Pretty tiny. Transformer. And good grief. Some of these parts are of interest to me. I'm looking for the big capacitor, Jim. Look for this big honking capacitor. It's probably up on top here. Wow. How about this thing practically hitting me in the eye? So that's probably it. It's a beauty. It's a beauty. So the likelihood of this being bad is not all that high. In fact, it could be, it could not be. It could be something else going on here. It could be that regulator circuit's not working properly for some reason, and that's why the power supply is failing to do its job. Well, or am I just totally full of crap, and in fact it all works, and the power supply works, and the hum I heard was something else, some other artifact of what it was doing? Let's set this guy up to operate. Okay, I think I'm ready here. So I've got a voltmeter set up to read the 12 volts that is entering the radio after the regulator. So I'm pretty sure this is the regulated voltage. I've picked off what I think is the correct terminal here, but this plug has turned me around so many times. It could well be that in fact the 12 volts is down here, but that's okay. So we'll start with it like this, and so I've got it plugged into dim bulbs. It's really maybe not the best thing, so I'll turn it on without the dim bulbs. And the on-off switch on this radio, if I remember right, was kind of wonky. Yeah. So we have it off. Okay. On. It's wonky because of this plastic rod here. Standby, single sideband, AM. Well, we'll just start it up on AM. Okay, I think we're ready to go. Speaker, we're not ready to go. I need a speaker. Weren't going to hear very much the way it was. Now, oh, that's right. Speaker output is shot on this radio. That's right. That's right. Got to do this a different way. Okay. Let me stop for a minute. I gotta do a little audio thing here. Okay, time to give them a try. Plugged in, power in, audio out, voltmeter hooked up, antenna connected. This should come on as soon as I do this. Okay, and a little bit of sound, please. How about this? Oh, there we go. See if we can stabilize the lock light. Can you hear the hum? It's very hard to stabilize this light. 9 volts. 9 volts, not 12. So, assuming I've got this connected correctly, I probably do now, we're way low. Feeding the radio with 105 volts. That may be part of the problem. Let's give it a shooting match here. This is jumping around too. When it goes high, the radio begins to operate. Okay, power off. There, you've seen it. Is that due to that capacitor? Wow. The voltage going up and down like that? A capacitor can't do that. Not directly, anyway. Maybe we're on the edge of the regulator's effectiveness, and so it's kind of regulating and then not. A capacitor's drawing down the voltage. Wow, it would get warm. It's drawing down the voltage that much. I don't think it's very likely, frankly. Let's look at this on the scope. Yeah, I should have done this right on the scope to begin with, I think. You can see the hum. We heard the hum. Why do we want to bother seeing it? So the hum certainly suggests a filtering problem. And the entire filter is made up of that capacitor. I could augment the capacitor at this point, just to add capacitance to it. I could test the capacitor. That's a little tough while it's in the circuit. We're going to look at the power supply hum factor here. Let's see what happens. Volts DC, and where are you? There you are. Okay, so I turn the set back on, and I'm going to turn the volume. Volume is down. I'll leave the volume down. Somehow I feel uneasy about all this. Here we go. Swoosh. Wow. I want to see what a power supply hum looks like. Look at that. That's pretty bad because it's 12 volts from here to here. So this is like a 2-volt hum here, and also it's not 12 volts. We're in 5-volt division. Check the zero. Zero is right on the center line. So we're looking at just under 10 volts. It matches what the meter's saying. And the meter reading is jumping around because the meter's taking periodic readings, right? It's not analog. And so occasionally it looks at it when the peak is there, and it looks at it when the valley's there, and gets that reading jumping around. I do believe that's the issue. So that's quite convincing now that this capacitor is just not doing its job. It's not doing its job. Before doing any more, I better find out if I have a suitable replacement. 500 microfarads at like 20 volts or something like that. So I'm very lucky to have acquired stock like this over the years. So these are all different kinds of capacitors, but look, I found one here, 560 microfarads, 200 volts. That should do it. So we want to test this guy out. Now, it's a big capacitor. Don't know if my little tester can handle a big capacitor like this. So this is the negative terminal here. It's got 3 terminals. They're numbered 2, 3, and 4. There it is. 2 and 4, no connection. 3, 200 volts, so it's just the third, just the 3 connection. Okay, fine. Comes with extra terminals for who knows what reason. What do you say? Can you do it? Can he do it? 615 microfarads, and it's supposed to be 560. ESR is nothing. V loss 1.2. Looks good to me. How accurate can this be anyway? 560. Can they? In the early days, these were very, very inaccurate. So often the early electrolytic capacitors were much higher in value than the stated value because the manufacturers couldn't control it that well, apparently. So if you bought like a 50 microfarad capacitor, it probably was a 100 microfarad capacitor. I got 2 of these. No, this is something else. This is 6,800 microfarads. That's a little too big. This will do. Now, what do we do with it? So I have the option of paralleling it in to see what happens. That would prove the need for it. Or I just go ahead and try to figure out how to install this. This is not going to replace the one on top. In the sense I'm not going to remove that big one up on top. I would somehow fix this in the radio here. Somehow is somehow being the operative word for it. Somehow. The leads that go to the existing capacitor way down under here somewhere. Hey, is this thing? We're not turned on here. No. No. Let me just be absolutely sure. Here. Of course, you're not going to get a high voltage shock off of this guy. So where are those wires? They are again. So this is the situation that often happens with these capacitors. They have multiple wires coming to the lugs, and this thing has what's going on here? It's got 1, 2. It's got 3 lugs. Three lugs. How's that work? It shouldn't have 3 lugs. I thought it was one big capacitor. Maybe this isn't the capacitor. Okay, the words are down under here. That's the speaker here. I'm taking off. Got to set the radio down to. Read the capacitor. There it is. What does it say? It says 300 at 25 volts. Oh, 3,000. What? Let's put the other camera on that. 3,000. Huh? What's going on here? Okay, we'll switch that camera. $3,600 and 600 for 85 degrees. Well, those numbers don't match up at all with what I saw. 3,000. Oh my gosh, we gotta find this. 3,000. Am I just making stuff up here? Okay, so yikes. Yikes. Synthesizer comparison chassis. Boy, if that doesn't intimidate you, I don't know what would. Okay, we'll look at this schematic again and find out what's going on with this honking capacitor. It really missed the mark here. So I think I made a classic human mistake here that I try not to make, and that is run with the first thing you see. Don't look any further. So first thing I saw was this. If I'd looked, excuse me, just a little bit further, it would have seen this. 3,000 microfarads here, 600 here, and the last 600, maybe it was actually 500, and it's probably here. That probably read it wrong, or they put a 600 here, even though it says 500. They used a 600. Otherwise, where's the other 600 going? Got to be here. So this is not quite the situation I thought it was. Now think about this for a minute, Jim. We got 12 volts here, but look, it's ahead of all this. What's going through my head is how can I make measurements to prove that the 12 volts is available in the first place. And it's 12 I was measuring. That's this one. How can this be pulled down? Beginning the don't go back here. The switch is the other way. So it's here. You know, I mean, I don't know. Could be this. Could be these. I doubt it, but, you know, I don't know. You'd have to guess it's this 3,000 guy. Oh, the picture has changed dramatically. What I think I might want to do is, because for all I know, this is the cause of the hum. I don't really know. And how am I going to deal with that? I've got better alternate power supplies. I have one here in the shop. And I could power this radio from the alternate power supply. It's quite neat. So I'm going to abandon this for now. It looks like too tough a go, and I have an what do they call that? An efficient alternative. So I'm going to make the economic decision to go with the. So we're going to go a different direction now. I'm going to get this other power supply. We're going to check its output voltage. Excuse me. The radio's calling for 12 volts here. And a lot of 12 volt systems are actually 13.8 volts. So probably it's expecting 13.8 here. I don't know for sure. Well, okay, let's do what I say. We'll check out the power supply, see what's coffee time. Okay, step one is testing the output voltage of this power supply. I believe, well, I know where that came from. This was operating a Motorola radio, but it doesn't say Motorola on it anywhere. Just says made in the USA, Astron. Actually, it says Astron Corporation. A model SL10 output, 13.8 volts DC, and I got the voltmeter hooked up to it. It's just no load. What does it do? Wow, it doesn't get any closer than that, does it? I think probably my meter's inaccurate. 13.78. So almost 14 volts instead of 12. But like I said before, even though this thing says 12, they're probably thinking car battery. The no load output voltage of a charged car battery is in question, and also an operating automobile with the charge, the alternator providing charge has a certain voltage. I'm going to find out what those are. I don't know. thought I would ask the Bing AI or Microsoft AI the question, Copilot. So I asked this question: what are the electrical voltages of a car battery on no load and the typical car voltage when the alternator is charging the battery? Here's the answers I got. Car battery's voltage can vary depending on its state and whether the engine is running or not. The no load, engine off, a fully charged car battery should have a resting voltage of around 12.6 volts. If the voltage drops below 12.4, the battery might be partially discharged. Well, 12.6 is what I'm after there. When the alternator is charging, the engine's running, the voltage should typically be between 13.5 and 14.5. This range ensures the battery is being charged properly and the electrical components in the car are functioning correctly. So this suggests if you were to hook this radio up to your car, the cigarette, well, I would like to check this in my car and see if this is really true. Really, 14.5? I've never heard of it that being that high. I thought 13.8, but I guess these are not precision. Well, maybe today cars are a little more precise, but I think I'm beating a dead horse here. I don't think there's a problem with hooking up the power supply. Well, it dawned on me that I could ask the Copilot directly the question I'm interested in. Here it is. My HRO 500 radio can run with a 12-volt external supply. If I connect my HRO 500 radio to an external DC supply at 13.8 volts, will I risk damaging the radio? And here's his answer. I think it's a person. The HRO 500 radio is designed to operate on a 12-volt DC supply, but many such devices can tolerate a slight overvoltage. However, 13.8 volts is on the higher end of what might be considered safe for a 12-volt system. Here's a few considerations. Tolerance range. Many 12-volt devices can handle up to 13.8 because this is a common voltage for automotive systems when the alternator is charging the battery. Manufacturer specifications. It's always best to check the manufacturer specifications or user manual for the exact voltage tolerance. If the manual specifies a maximum voltage, exceeding it could damage the radio. Heat generation. Higher voltage can lead to increased heat generation, which might affect the longevity and performance of the radio. To be on the safe side, you might want to use a voltage regulator to ensure the supply stays within the recommended range. If you're unsure, consulting the manual or reaching out to the manufacturer. I'm not so sure about that. Reaching out to the manufacturer. Do you have a manual for your HRO 500? Would you like help finding more detailed specifications? Yes. I say yes. Please find the HRO 500 specification for the 12-volt supply, specifically the range of acceptable. Fortunately, this thing can understand my spelling mistakes. I don't have to worry about it. Specifically, the range of acceptable voltages. Voltages. It would still know what I'm doing. Voltages. I didn't drink enough coffee before doing this. Specifically, the range of acceptable voltages. Especially, is that really a word? 13.8 volts DC. Okay. Let's see if it can actually do this. I found the manual, which oh man, okay. I found the manual for the HR 500, which includes specifications of 12-volt supply. According to the manual, the 500 is designed to operate 12-volt DC supply and can tolerate a range. The acceptable range for the HRO is typically between 11.5 and 14. Therefore, the 13.8 supply should be within safe operating range. There you go. I'm living in a world with AI. Fantastic. Okay, we're going to give it a go. Okay, so once again I have this meter connected to the 12 volt test point and the big connector in the back, so we can see the 12, but it won't be 12, it'll probably be 13.8. And I've got the power supply connected to the positive input terminal, yes, ground on there, and I've got the speaker, I've got a feed over to there, which is humming right now. Why so much hum from it? Let's see what happens when we turn it on. So no, so that hum you just heard, that's with this thing not operating. So I'm not sure that's going to go away. So I also got the switch on the back set to 12 volts. As soon as I hit the switch, the radio should come on. The volume we want it down. RF can be up. Band choice can be here. That's 4 to 10 megahertz. That doesn't matter. And we're ready to go. Just watching the positive lead here. Is a little wiggly. If you wiggle enough, it'll short right out. You don't want that to happen. It's hard to keep an eye on everything, so don't rotate the radio jam. We do not have the antenna connected. Hold it. Just a second here. Too many wires in the shop here. No, come on. There it is. Okay, now we have a fairly good outdoor antenna connected to the radio too. Deep breath. Everybody take a step back, just in case. Volume's down, and the volume on my board, I'll put it up a little bit. Okay, so we're listening. Power on. Bit of a hum there. So according to this, we're tuned around. Turn it down. Oh my gosh, I haven't got it turned up at all. Yeah, you know, wait a minute, I gotta flip a button on my board here. Set it to line. That's better, I think. So what I did was my soundboard there, I had it set to microphone, and that's just too sensitive, so now it's set right. Okay, phase lock, light is out, which means the radio is in, the synthesizer tuning is set correctly for 8.5, so now we're at 8,670, but that's a little low. We really want to be up 9, so we're going to go up to the next. I'm so impressed that this radio works, really. Okay, so now we're 9,170, and we want to go up to around 3. Wrong way, 170. Somewhere up around here, we should pick something up. You know, I don't get the impression we're picking anything up. Oh, pre-selector tune. Always forgetting this. Yeah. This is so critical. There's basically 2 tuning knobs on this radio.
The living God.
Look at that strength.
As long as it is still called today.
We put on the AVC.
Wow, I think that's interesting. Deceitful. Sin is deceitful. It's deceitful in that it seems like you're getting something through sin that you might have wanted or desired.
Sounds overloaded.
Actually, it's going to overthrow you, your faith, your hope.
Turn way down. Turn up on the.
For we have become partakers of Christ if we hold fast the beginning of our assurance firm until the end.
Wow, there's that if again.
Well, yes.
Isn't that striking?
Verse 15, while it is said, today, if you hear his voice, do not harden your hearts as when they provoked me.
Yeah.
For who provoked him when they had heard? Indeed, did not all
accuracy
those who
is
came out
stunning.
teach him?
330 right there.
Wow. And Moses here is the prototype of Christ, do you think?
Oh, very much.
Yeah.
Exactly.
So those who then rebelled
I'd say the center is right around
in
here.
Moses'
So
days,
it's,
he's
it's
going to
amazing.
compare to those who now are led out by Christ.
Let's see what else we can find here. This is 9.5. So this is a little low for this time of day. We should really be, you know, maybe the 19 meter band. So we'll turn the volume down. 19 meter band is 15 megahertz. So we want this to say 15. 15.5. How come the light's not going out? There it goes. So 15.5. And we add 270 to it. We should get a station. Let's see. 270. Anybody there? Ooh. Yeah, something zero. Right? Well, there's a station at 152770. 15770 rather. 270. It's wiped out by this thing. I don't know what the thing is. Let's go down to 15. That's 15.
Co-pastor of Praise, Power, and Prayer Temple. Write to us at Box 474, Windsor, Connecticut 06095.
15320.
That address again is Box.
I don't know if there's a station. Well, there's a station there. We can hear it.
06095. The book called The Unbreakable Covenant of Marriage. To get a copy of The Unbreakable Covenant of Marriage, call us at 860-285-8898. That phone number again is
It's definitely got
860-285-8898.
it's sort of a distorted sound to it.
My name is Joshua McMahon. On behalf
Hello,
of my
Josh.
dad.
See you, Josh. Well, I think I've achieved what I wanted to achieve today.
Near. With your hectic and busy schedule, has your prayer life been affected?
The prayer life. That's where you kind of just go like this, and then you communicate with the maker of the universe.
SupremeMasterTV.com
Oh boy, Supreme Master.
SupremeMasterTV.com/AW.
Nothing new in religious organizations utilizing radio to get their word out. Going down towards 15 here. 15 right here. Anybody here at WWV? Get a little bit past on this knob. Well, I don't hear it. Is it there to be heard? We'd have to get another radio and find out. But that should be 15 megahertz right there. Can we get up to 20? We can go all the way up to 20 on this. Do we try? Let's go. Whoop, not that. This. 20. Oh, there's so many knobs. I'm going to have a great time with this radio. 19, 19.5. I guess this is 20. They didn't... Oh, it gets to 20 from 19.5. Okay, well, we can do that. We just have to go to the other end of this dial. This is the downfall of this radio. It's the best thing and the worst thing. Doesn't sound like much is happening up here. Not hearing anything. Oh. No WWV though. No. Well, I don't know what that means. Okay. So the situation is I'm able to operate this radio just fine. So it's going back in its operating place. I'm going to operate it from this power supply on a permanent basis. Abandon the internal power supply for now. Anyway, who knows? Years from now, maybe I'll do something with it. Who knows? But this is working quite fine like this. So I'm happy to keep it this way. Fantastic. Okay, that's it. That's it for today. I got to get another radio in here for tomorrow. But I certainly have a few. You want to do a big one? What if we do a big one? I know what I'm going to do tomorrow. I've got 3 or 4 similar radios, and I'd like to judge the condition of each one of them before starting into working on any of the 4 of them. So tomorrow we will compare four radios. Oh my God, really? Yeah, we'll try it. See ya.